Going to explain about the string matching algorithm using finite automata. String matching using the finite automata. Finite automata is of two types, DFA and NFA. Firstly, we need to compute the transition function, computation of the transition function, in which we send the pattern as the input, and in the next we have to automata matching algorithm, in which we send the text as the input. Firstly, computation of the transition function, we need to send the pattern and the symbols list as the input in this. For this, the algorithm is m, which is the length of the pattern, and for q, from ranging from the 0 to m, we have to do for each character a, which is belongs to the closure of the symbols, we have to do k until minimum of the m plus 1 and q plus 2, where m is the length of the pattern and q is the states. We have to repeat this for k is k minus 1 until transition of q comma a is k, that is for every state there is no transition, then we have to return the transition. This is the algorithm for the computation of the transition function. Now let us see the algorithm of the finite automata matching algorithm, in which it takes the input as text and transition and the length of the pattern. This takes these three inputs. In the algorithm is n, which is the length of the text, and initially q is 0. For we have to run a for loop for I, which is from 1 to n, which is the length of the string, actual length of the string which we send as the input. We have to do q is like transition of the q of t of I, and if q is equals to m, s is I minus m, then we have to print that the pattern is found at the position I minus m minus 1. This is the algorithm for the matching finite automata matching algorithm. Let us see at an example. A finite automata which accepts all the even number of a's. In this, the symbols list is a, b, c. Here q0, let q0 be the start state, and upon a and q0 it goes to the state q1, and upon a it again goes to the q2, which is the final state. And when we give b and c, it goes back to the q0, and even here it goes back to the q0, q1, and even here it goes back to the q2. And upon a, when we give to q2, it goes back to the q1. This is the finite automata which accepts the even number of a's. We have to draw the state transition table for this. We have to draw the state transition table for this. We have to find the string matching. So here we have the states q0, q1 and q2, and the symbols a, b and c. And here when we give A onto the Q0, it goes to the Q1, and when we give B onto Q0, it goes again to the Q0, and when we give C, it goes again to the Q0, and when we give A to Q1, it goes to the Q2, and when we give B and C, it goes back to the Q1, and when we give A, it comes back to the Q1 state, and when we give B and C, it goes back to the same state. The given text in this question is B C A B C A B A C. This is a start state. When we give B to this, it goes to Q0, and when we give C, it goes to the Q0 again, and we give A, it goes to the Q1 state, and when we give again A, it goes again to the Q2 state, and when we give B, it goes again to the same state B, when it goes again to the same state Q2, and when it gives C, it goes back to the same state again Q2. Upon giving A, it comes to the Q1, and upon giving A to the Q1, it goes back to the Q2, and upon giving A to Q2, it comes again back to the Q1, and B, when we give B, it comes back to the Q1, and when we give A, it comes back to the Q2, and upon giving C, it comes to the Q2, which is the final state, which means the string is accepted by the automata. And we'll see another example. This is finding the pattern A B B A in the text string A B B A using the string matching algorithm. String matching with the finite automata. We need to draw a state table. We have A and B as the symbols here. So firstly we need to draw the finite automata for this, which is 0 is the start state, and upon giving A, it goes to the 1, and upon giving B, it goes to 2, and upon giving B, it goes to the 3, and upon giving A, it goes to the 4, and upon giving B, it goes back to the same thing, and upon giving A, B, and for the state 1 it is A, and from the state 3 this is the finite automata given. So we have the states here as 0, 1, 2, 3 and 4, and on 0 if we give A, it comes to the state 1, and on giving B, it goes to 0, and for 1 when we give A, it comes back to 1, and when we give B, it goes to the state 2, and in the same way upon giving A to the 2, 1, upon giving B to the 2, it goes to the 3, and upon giving A to the 3, it goes to 4, upon giving B, it goes to the 0, and even for the 4, it comes to 1, and it goes to the 2. This is the state transition table for the given finite automata, and the given text string is A B A, and the pattern given is A B A. String which is given is A B B A, and the text string is A B B A, and for I we have values 0, 1, 2, 3, 4, 5. This is the length of the string, which is a 6, so we have from 0 to 5, and the T of I is the string which is this A and B B A, Now we have to find the pattern whether it's there in the string or not. So this is the position, shift position, and upon 0 upon 8 comes to 1, and 1 upon 8 comes to 1, as we can see from the transition table, and 2 upon a it goes to the 1, and here 3 upon b it goes to 0. So 1 on b is 2, and 2 on b is 3, and 3 on a it goes to the 4, and here we can find that a b b a we have this, and at the position 1 this will accept by the finite automata and print